Hi, my name is Rodrigo Gutierrez, currently a junior scientist at AIT, the Austrian Institute of Technology. Welcome to this presentation, and thanks for your interest in this study titled Effects of Biofeedback-Informed Soundscapes on Well-Being and Cognition in Indoor Environments. The motivation of this study arose from the comprehensive understanding of the acoustic environment, integrating the subjective perception with the more traditional methods of sound propagation. This concept of soundscape as a mental construct helps the design of spaces that facilitate cognitive performance and health, and it has been developed in the ISO 12913 standard as an effort to structure the systematic analysis of our perceived affective quality regarding the acoustic environment. Along with this line of thought, in this study we proposed an oscillating sound of nature to support slow-paced breathing, and see how this helps mask surrounding noise, aids the cognitive performance, and supports measures of health and stress. For this purpose, we established some research questions and a hypothesis as follows. What are the effects of an augmented acoustic office environment with an optimal breathing guidance made of natural sounds on the different dimensions of our perceived affective quality? For this, we used ISO 12913. How does this acoustic environment and corresponding soundscapes influence the executive cognitive abilities associated with attention? For this, we used a cognitive task. And are the elicited soundscapes healthy? Do they lower the stress level? For this, we looked into physiological measurements. The whole hypothesis is that soundscape dimensions of the perceived affective quality model in ISO 12913, influenced by this breathing guide of natural sounds, would improve cognitive performance and health. So we set up three sound conditions that we wanted to study as our input independent variables, being the first one silence, the second one sounds of office space, and the third one, the same sounds of office space, this time mixed with the oscillating sounds of nature, which oscillating frequency was set to each participant's optimal breathing rate. And for each condition, the participants had to rate the sound with the ISO 12913 method A Likert scales, such as the sound source identification, whether they perceive more office sounds or natural sounds, with the perceived affective quality, whether the sound was more pleasant or annoying, for example, with the sound assessment, whether the sound was good or bad, and the sound appropriateness, whether it was appropriate to the space that they were in. We measured cognitive skills with a reading span task that had mean reaction times, mean errors, and partial credit scores. And we measured the physiological signals with heart rate variability, skin conductance levels, and temperature. We also provided questionnaires about personality traits, a short one, and also Barkley deficits of executive functions, which is a measure of executive abilities. And of course, we had these conditions changed in order for every participant. Every participant was treated with the three sound conditions in a listening room with 5.1.2 speaker systems. The office space was recorded in a real environment with an ambisonics microphone and then rendered to the speaker system. Every participant had to perform a reading span task consisting of a series of words that they had to memorize and then recall after reading some sentences and judging them if they were right or wrong. All this out loud. And all their biological signals were measured at the same time. And on the third sound condition, they were provided the oscillating sounds of nature at their optimal breathing rate through the open back headphones. And they were asked to rate their breathing at the guidance that they were provided through the headphones. And they could do this also in the other conditions, but without guidance. The results of the ISO 12913 method A Likert scales are shown in this graph, and they show how, for example, in blue, how the silent condition was perceived as more pleasant, more calm, less annoying, more monotonous, and more uneventful than all the other conditions, which is to be expected. And on contrast, the office space was perceived as more chaotic, less calm, less eventful, and also more vibrant and eventful than the silence, which is also what we expected. And what was good is that in the middle between those two, the oscillating sounds of nature that were added to the office environment were perceived as more pleasant than the office, more calm than the office, but also just as vibrant and very close to eventful as the open office. So this is what we were expecting, because we wanted a calm environment, but also they had some elements of vibrance and eventfulness, so as not to be too relaxing, but more cognitive and focused attention directed. The results of the reading span task provided no meaningful statistical difference between the three sound conditions. But we can see on the left, in the graph in the left, how the condition 3, the sound condition with the breathing guide made of sounds of nature, had a negative impact overall on the reading span task. So for example, it has slightly lower partial credit scores, higher mean reaction times, and higher mean error. But when we saw a further analysis in the order in which they took the test in every condition, then we saw also some interesting insights that we can see on the right graph, being that, for example, in the middle, the results of the partial credit scores were just the same for condition 2 and condition 3. So there was basically no difference between the office space and the breathing sound condition with the natural sounds. And the same was for the third time around. And so we explain these insights a little further in the following sections. The physiological signals also show no statistical meaningful difference, but some interesting results can be observed on the graph to the left. On the HRV side, we can see how every participant exhibited high HRV levels, meaning that they all were, in some sense, slow pacing their breathing, because they were instructed to do so. They were told that they could slow pace their breathing in every sound condition. Only in condition number 3, they had an explicit guide to do so. And this can be also observed in the standard deviation from 6.16 to 10.40 in condition 1 to condition 3, that the attention that was required to follow the slow pace breathing had exerted more effort to the participants. We found that the identification of sounds of nature was related with higher HRV measures, that the perception of E3, the sounds of nature, as calm also indicated higher HRV levels, and the perception of E3 as vibrant also had higher SCL levels, skin conductance levels, indicating more arousal, which is also what we wanted for the design of this acoustic environment. So what we gathered from the results of the analysis is that doing the reading span task plus the biofeedback was very complex for the participants. We were asking participants to do a cognitive task while trying to relax at the same time. And this is something we wanted to look at, not a relaxation as post-stressful task, but during the same task, to see how participants would distribute their attention. And this brings us to the topic of rhythms of attention, that self-control is a value-based choice. What is that you are prioritizing to do? So this is the behavior that we wanted to observe during the reading span task. Participants found little segments where they could slow pace their breathing and then continue with the task, but they had to switch between one or the other. So your attention will also be focused on one task or the other. This was a study of decision making. The participants had to decide what to do best, the reading span task or slow pace their breathing. And for this, we used the Soundscape Studies Standard ISO 12913, which is a work in progress, which needs some improvement in the direction of the psychological signals associations with physiological measurements. Improving the design of this experiment will include a reading span task that doesn't require the participants to read out loud, and that would improve their ability to slow pace their breathing. But overall, we call this the interoceptive augmented acoustic environment, which is a soundscape that provides you a guide of how your internal body is working. And so you have this in your environment and are provided a way to take care of your body in a better way. And perform better in cognitive performance, executive functions, and associations with the soundscape. The ultimate challenge here is to get closer to the physiology of subjective perception, which again should be something that has some room for improvement in the ISO 12913. Thanks for your attention, and I'm open to questions and answers in the email or otherwise. Thank you very much.